Hello, I am so excited to talk to you today about how matter changes. Matter sounds like a really sciencey word, but it really just means anything you can describe with the word stuff. We see matter change all the time, and today I want to help you break down the two ways matter can change. Before we get started, we have to look at some key facts that you need to know about. The first is that matter or stuff is made up of very small particles called atoms. There are different types of atoms, and each one has a different size and mass, which is kind of like its weight. These atoms, just like humans, don't like to be alone, so most of the time they end up in groups, and these groups are called molecules. And these molecules, they can be made of the same kinds of atoms, or they can be made of a combination of different types of atoms. So one of the most important things that you need to know about atoms is that atoms are forever. Now, what does this mean? Well, it means that no more atoms are being created and no more atoms are ever going to disappear or be destroyed. Because of this, when you're hungry and you grab an apple and you eat it, eventually only the core is left, right? Well, the atoms that made up the apple, other than the core, they didn't just disappear, they actually just moved into your body. This brings us to another aspect of matter, that it can move. All matter can move. It just needs something like a little help from energy. So let's just pause our discussion on matter for a minute and talk about energy. Energy is something that you probably have all heard about before, but what actually is it? Maybe your parents, they've told you to turn off the light switches so that you don't waste energy. I know my parents did that. Or maybe you know that if you want to have enough energy to run a new PR in a race, you have to eat the proper amounts of foods and the proper kinds of foods to do that. Both statements are true because of energy, and I'll explain why. So energy comes in countable units. We know this because our electric bills are decided based on how many units of energy we use through our lights, our outlets, and so on. Our food is also labeled in energy units, and these are known as calories. For example, 2 eggs provide about 140 calorie units of energy, while a slice of bacon might give you 45. Just like matter, these countable units can move from one place to another, and thank goodness. In order for our phones to have battery to function, electrical energy must travel from the power lines to the cables in our homes, to the outlets through our chargers, and into the battery of our phones. This is energy being transferred from one place to another. After the electrical energy makes it to our phones, it's transformed into light energy, maybe sound energy, and sometimes even mechanical energy to vibrate. And this is a really important aspect of energy. While energy is something separate from matter, the two are always working together, kind of like how shirts and pants are completely different things, but they always need each other. In fact, when matter moves or changes, energy is always involved. What you need to know next is that there are different types of energy and that there are different types of matter. Energy comes in many forms, some of which can be light energy, mechanical energy, sound energy, chemical energy. You can have heat energy, gravitational energy, and nuclear energy, and many more. Matter comes in 3 different forms or states: solids, liquids, and gases. Heat energy and chemical energy play a huge role in changing molecules of matter, and we're going to look into that a little bit later. Now that we've covered most of the basic information you need to know about physical and chemical changes in matter, let's get going on how exactly that happens. We'll start with physical changes. Physical changes occur when a substance changes from one state of matter to another, but it is still the same substance. In order for this to happen, heat, or sometimes called thermal energy, has to be either added or taken away from the substance. It's time to move in and take a closer look at the molecular level scale, which means using a model to analyze the system of the moving molecules. In solid matter, the molecules of a substance have very low energy of motion, which is another name for thermal energy, which allows its molecules to have a small push-apart force, causing them to vibrate against each other, and end up closely packed to one another. Liquids are made up of molecules that have a slightly higher energy of motion than solids. The additional energy allows the molecules to have a stronger push-apart force, leading to a sliding motion of molecules in a close but not too closely packed arrangement. Gases have the highest energy of motion. Their push-apart force is huge, making the molecules of a gas bounce off each other and create a far distance between one another. See the differences? Now I know what you're wondering. How do they get from one state to the other, and what exactly does this mean for my everyday life? For this, we turn to experiment number 1, the butter and the hand. One night, I sliced off a pat of butter from a cold fridge and placed it on my room temperature hand. Butter is a solid, therefore its molecules are closely packed together and vibrating against each other with a low push-apart force. Once the butter touches my hand, however, something happens. Heat energy from my hand transfers from my hand into the butter, and it starts to increase the push-apart force between the butter molecules, making them slide past each other and have a closely packed arrangement. Does this ring a bell of anything? Oh yeah, a liquid. So here, I'm drawing a paperclip model. And on the left side is a scale, and I'm making a bunch of butter molecules. We don't know exactly what's in them, so we're going to represent them with what would be paper clips. And these paper clips on the left side, they weigh 20 grams. On the right side, I'm drawing the same paperclip models, but just a little farther apart. And how many grams do you think they might be? 20, exactly. So what we see here is that it's the same substance. The molecules, when thermal energy is added, just get a little bit more spread out. The next model we can use is something called a change in energy template. Now, for a change in energy template, we start with something, we'll give a random number of maybe 17 thermal energy units in my hand. And that ends up being 17 thermal energy units in the butter. So as you can see, when thermal energy is added to the butter, even just a little bit for a small amount of time, that thermal energy makes an impact on the sides of the butter and it starts to melt right in my hand. Next, what we're going to talk about is chemical changes. And chemical changes are a little bit different. So we're going to look at this experiment that I did with the stains. And do you see the ketchup and the blue pen? Well, we're going to use the ketchup as our main example here. So with chemical changes, we're going to start with, not the paperclip model, that was a mistake. We're going to start with looking at the molecular level. So just like with physical changes, molecules are involved. And in this case, do you see we have different kinds of molecules here. So sometimes atoms, just like friends, like to change their friends, right? So atoms in some molecules, they become attracted to atoms of different molecules. And over here on the right, I'm drawing these atoms, the same atoms, put in different groups. And this is what happens when there is a chemical change. Chemical energy is used to break apart molecules and put different atoms in different groups. Well, the same atoms in different groups. It's a little confusing. Here's the paperclip model. So we have our atoms here, right? So say these are going to be our ketchup molecules made up of a bunch of different kinds of atoms. And on the left side, we have a couple of different kinds of molecules, right? And then on the right side, we have different molecules than the ones that are on the left. And they're different molecules, but the same atoms are used. And you see that they have the same masses too, and that's because the same atoms are used. Now next we're going to look at our change in energy template. And just like before, we want whatever is on the left side to equal the number of units on the right side. What's different here though is that chemical energy is used in the change, and we have 10 units of chemical energy in our ketchup and 15 units in OxiClean, which was going to be used to try to take off the stain. That equaled 25 chemical units total in our new molecules. Now, let me explain this a little better. In our first column, we have our stains that we didn't try to treat at all. Our second column, we tried to get rid of the stains with OxiClean, and in the third column, we tried to get rid of our stains with baking soda. Now, as you can see, none of the stains really got taken off. And why is this? Well, the atoms in the OxiClean and the baking soda, none of them are really too attracted to the atoms in the ketchup or the blue ink, so they didn't break the molecules of those substances apart and clean them off. Now for a quick recap, molecules are made up of atoms which make up all matter, and matter can be changed with the help of energy, either chemically with chemical energy or physically with heat energy. And for our last activity, we're going to use our paper clips with the real scale. Now what I'm doing here is I'm placing 3 molecules of a solid on the scale, and because they're solid, they're closely packed together. And we're going to see what their weight is. It looks like 3.8. Now in our physical change, what happened was heat energy was added, and the molecules just become a little bit more spread out from each other because they have that extra energy. Still same substance, but just liquid. And look, still same weight, 3.8. Now what we're going to do over the next one is we are going to look at, pretend the ketchup and the OxiClean work, right? So those first couple of molecules are going to be our ketchup molecules, and these blue ones are going to be our OxiClean. So first when they come into contact with each other, they're separate molecules. 4.9 is their mass. Now when they become attracted to each other and the molecules break apart and they form new molecules, here are our new molecules, same atoms, just in different groups, right? So let's see how much they weigh when they're arranged like this. 4.9. It's the exact same. Well, I hope you learned a lot about physical and chemical changes, and have a great time being able to point them out in the rest of your everyday lives.